Hello everyone. So now we are going to discuss about this one, troubleshooting static dynamic 802.1q trunking protocol. So here we need to do the troubleshooting, but before going to the troubleshooting, first of all we will check what is the 802.1q trunking protocol and how we can configure static and dynamic. Then we will do the troubleshooting lab for this one. So let's start this one. So what I will do, first we will discuss some theory about this one. After that we will do the lab. So already we discussed in our previous class, whenever we connected two switch together, we need to create the trunk in between that one. Let me show you here. Let me draw here so you will have idea what we discussed in our previous class. Imagine I have the switch 1, I have another switch 2, and we have the connectivity between this switch. So then we need to make this interface as a trunk. Example, if I have the fast Ethernet 0x0, we are calling this uplink. We are calling uplink. When we are connecting from one switch to another switch, that link we call as a uplink. So what we are saying this one, when we connect any interface in between two switch, we need to make this interface as a trunk. If we did not make trunk, he is not going to carry the multiple VLAN. It is going to carry only one VLAN. So let me show you. Maybe you will understand with the basic lab. So let me do one basic lab. We can do in the GNS or EVNG anywhere, or we can do basic lab in the packet tracer, so you can see the packets also. So let me show you. So we have two types of protocol. Before doing that one, let me show you. So what I am saying, I will take two switch, okay, layer 3 switch I am going to use, two layer 3 switch. Let me make this big. So I have layer 3 switch here. Let me rename this one. This is a switch 1 and this is a switch 2. Switch 2. And we will have in between this will one link. Okay, an example, if I take any PC here, let me take two PC here, and one laptop here, one laptop here. This is basic lab. We learn in CCNA level this one, but anyhow to explain this concept clearly we will do again, so you will have more idea before going to the this 802.1q trunking protocol. So here I will connect this some PCs with this one, and we will create some VLAN. Imagine this is a, these two PCs are in different VLAN and this one in different VLAN, and this two PC in different VLAN, this one is different VLAN. So let me put some coloring here so easily you can track which belongs to which VLAN. So I will put this green color here and green color here. So this is from the same VLAN, and I will put any other color. Maybe I can take this sky color. This will be in the different VLAN. Imagine these both are from that VLAN. Imagine this is the ground floor or first floor. Maybe this is a ground floor, this is a first floor, some scenario like this. And I will give here, imagine this is a VLAN 10. Okay, VLAN 10. This is a VLAN 10 and this one is in the VLAN 20. VLAN 20. And this one is in the VLAN 10 and this one in the VLAN 20. VLAN 20. Any name we can give. Imagine, let me give the name here. Let me take, this is the HR department. Okay, this is the green one is the HR department, and here also HR, and here we will say IT department or any department. I will say IT. Here is IT. Now what we are going to learn here, first of all, how we can create VLAN. We already discussed this in our previous class, but anyhow if any new guy who don't know and who join later, he can understand here. Basic VLAN lab with two switch, because we are going to use two switch here. Okay, so what we will do, first of all I will create switch 1 configuration. Here in the switch 1 configuration I will write switch 1 configuration Same thing as we do before, like enable config t, then we will write the host name as w1, and after that we will create the VLAN. Example, I am saying VLAN 10 and we are giving the name as a HR. So I will give HR, then we will have the VLAN 20 and I will give the name as a IT. Okay, and then what we will do like we will put that port in the interface. So I will write interface range and then fast Ethernet 0x2-3. I am taking this multiple interface, this two interface. So I will write range command, and then we will write switch port trunk encapsulation dot 1q. Because we are using layer 3 switch, so we need to write this command first. If you are using layer 2, then you can write directly switch port mode trunk, directly you can write, but we are using layer 3, so we need to write this command also, switch port trunk encapsulation dot 1q. So with this this command is used to make the interface as a trunk. So here we need to put this command in between these two switch. Okay, so let me make here changes. What I will do here, I will do like this. This we will do as 0x1, like this way. Okay, so let me explain. Maybe some guys will confuse here. What I am saying, this two interface is in the which VLAN? VLAN 10. So we will make the access port and we will put in that VLAN. This one we will make as a trunk. When we want to make the as a trunk, then we need to write as a switch port trunk encapsulation dot 1q, because we are using the layer 3 switch. If you are using layer 1 switch, layer 2 switch, then directly you can put this command. But when we are using layer 3 L3 switch, then we need to put this two command. Already we know this one as per our CCNA level, we learn this one. So now I will remove this range because we are using only one interface. Now we have this two interface, we need to put in the same VLAN. How we can put? We will write here switch port axis or switch port mode. We can first create this as a axis, switch port mode axis, then we can write switch port axis, which VLAN? We need to give that VLAN number. This is the VLAN 10. Okay, so I put this in VLAN 10. Now I want to put the interface, that is a fast Ethernet 0x4, this interface. If you see this interface fast Ethernet 0x4, we will put here in that one. So what I will do here, I will write here interface fast Ethernet 0x4, and then we will write here switch port mode axis, and then switch port axis, which VLAN? This is a VLAN 20. Okay, so what I am doing here, I am creating the this interface will belongs to VLAN 10, this interface will belongs to VLAN 20, and here what we done, we created this as a trunk because it need to carry the multiple VLAN. Okay, so what we will do now, let me write the configuration for the switch 2. So let me copy the same configuration, we will modify depending upon here. I will copy whole thing here, I will paste here, and I will change this one as a 2 here, and then here also 2, and this we need, so this will remain same, and here this F0x1, okay, this is okay, no problem. And here if you see this interface F0x2 and F0x3. So let's see what we have here, F0x2 and 3, this is in the VLAN 10, so this also okay. And if you see this interface is F0x4, so this one also in the that VLAN F0x4, this is also in that VLAN, so this configuration is also valid. So let me paste this configuration. I will not put the trunk configuration, we will put later. I will copy this one whole configuration, I will put here. Okay, I will go in the CLI of the switch and I will paste the configuration here. I will write no, and then I will paste this configuration here in the CLI. So no error, nothing, everything is good here. And now I will go to the switch 2 and I will paste this configuration in switch 2. I am not pasting the trunk we will paste after some time. So now I will go here in the CLI, I will go here, I will paste here, I will write no here, and I will paste here. Okay, so everything is good. If you want to check, we can check also. You write show VLAN brief, so we have the VLAN, 2 VLAN, we have 10 and 20, and these ports are also there. You can verify the ports as per our requirement we have or not. VLAN 10 will have the 2 port F0 by 2, F0 by 3. This one is good. And VLAN 20 is having 1 port F0 by 4. This one is also good. So no issue. Here also we can verify. How we will verify? We will write show VLAN brief here. So everything is good here also. And if you see what we have, 2 VLAN we created, and same scenario, 2 port for the VLAN 10 and 1 port for the VLAN 20 we have. Now example, this guy want to ping this guy. Let me give any IP here, so this guy can try to ping and check. So I will write 192.168.1.1. Let me assign this IP here inside this laptop. I will go here, I will assign here, okay, and let me assign here also any one PC here also. I will give here 1.2, and then I will paste here. I will assign to the desktop also. I will give here 1.2. Okay, this is the same VLAN. Okay, and this is a different VLAN. I will give here also 1.3, and I will assign here also. I will go to the desktop. I will assign here. Then I will go to here also, and I will assign here also. Let me assign here. I will go in the desktop, and then here we will assign. Okay, so what we will do, let me ping from here to same VLAN should communicate. Okay, same VLAN should communicate. Let me check first of all I have IP or not. IP config. So I have the IP 1.1. I want to ping this one 1.2. Okay, this PC 1.2. So let me check ping 192.168.1.2. It is not working. It will not work because this one is in the VLAN 1. This interface in the VLAN 1. So it is going to carry only VLAN 1 traffic. Okay, this interface is in the VLAN 1. He is going to carry only VLAN 1 traffic. It is not going to carry multiple VLAN traffic. That's why we need to make this one as a trunk. So what we will do now, we will put the trunk configuration, but we verify here. Okay, it is not working. Why it is not working? Because this interface fast Ethernet 0 by 1, if you check that one, this interface is in the default VLAN, that is VLAN 1. So it will not work. So we need to make that as a trunk. So what I will do, I will copy this trunk configuration and I will paste here. And if you, or before pasting, let me show you one more thing. We have 2 protocol. Okay, we have 2 protocol to make as a trunk. But here in the packet tracer, we cannot do the 2 protocol because all the images of the switch here is upgraded. Old switch is having option for 2. But anyhow, let me do here. Let me show you here. What I will do, I will go to this interface fast Ethernet 0 by 1, and then we write switch port, and then I will write trunk, and if I press question mark here, I have switch port mode trunk encapsulation, and if I press question mark, I have only one option here, .1q only. We don't have any other option because in new router, new switches, we have only one option now, but in the old router we have 2 options. We have ISL also. We are going to discuss what is ISL, but anyhow we have only one option here, .1q. So I will do the .1q, then we need to write switch port mode trunk. So now it become as a trunk. One side I make trunk, so it will become other side also trunk. If you want to verify, we can verify also. And now if you want to check show interface trunk, we can write and we can check. So now it is showing us this is the on mode. It is saying that manually someone done this interface as a trunk. So this one, how it is become as a trunk, just now what commands we put the encapsulation .1q. So this guy become as a trunk by using the encapsulation .1q. Here we have that one .1q and status is trunk, and it is in the native VLAN, whatever native VLAN we have. So what we are seeing here, this is on mode. Okay, on mode. If you see in our syllabus, what he is saying, static and dynamic. On mode means static, and if you go here and if you check here, because here we did not make as a trunk, show interface trunk, this command we used to check the trunk. If you see here auto, we have auto means automatically it is created, that is known as dynamic. So here we have troubleshooting static dynamic 802.1q trunking protocol. So static means manually we configure. On mode is also known as static. If you see here in this one, it is showing on On mode means static, and if you are having auto means dynamic. So these are the difference between the auto and the dynamic. So what we are saying, when we create the trunk in this interface, the uplink which we create, that uplink is connected to which other switch, that port automatically becoming as a trunk. Okay, that is DTP by using the dynamic trunking protocol. We are going to discuss DTP also. What is DTP? So DTP is a protocol which is going to make the trunk other interface. If we make trunk here, automatically it will make other interface as a trunk. And now we can ping some PC and we can verify. Example here, let me show you.
Sir, one question. So if there were, let's say, two switches, switch 2 and there is another switch 3 connected to switch 1, so if we make this interface trunk, it will make all the switches connected yours only connected to that interface. Okay.
Only directly connected.
Okay. Directly connected.
Yeah.
Got it. Thank you.
Okay. So what we will do now here, I will ping one packet. Here. Let me ping here, or first of all let me enable the simulation mode. I enable the simulation mode, and I want to send one packet from this PC to this PC. Okay, so we have the ARP, as we already discussed, address resolution protocol. We have, it will go that one, it will broadcast, and then he is going to get the MAC address. If you see, it is broadcasting in the same VLAN only. It is not broadcasting in this area because this one is not belonging to the VLAN 10. If you see, it go here only. So what we can say, in our previous class we told VLAN reduce the broadcast domain. As we told, VLAN reduce the broadcast. How it reduce the broadcast? It divide the broadcast domain from the single broadcast domain into multiple broadcast domain. So now this is a VLAN 10 traffic, so it will go only in the VLAN 10. We will not have the broadcast here. In this area we don't have the broadcast here. Okay, so what we are saying here, in this area we don't have the broadcast, in this area we don't have the broadcast. Just now we check, even if we have the broadcast packet, as we discussed in our previous class, ARP, address resolution protocol. Address resolution protocol is a broadcast packet. This packet is a broadcast, as we checked before. So this need to go to all the interface. But if you see, it go here, here, and here. It did not go here. It did not go here. Why? Because VLAN used to reduce the broadcast. VLAN create the single broadcast domain into multiple broadcast domain. Okay, so now anyhow we have the R packet, and it will get back, and if it will take the MAC address, and it will go back, and it will give to that switch, and then that switch will forward the packet. If you see this packet I receive, I will open this packet. If I open this packet, what I will have here in this packet? In this packet here, this is a inbound, means this packet is going inside to the switch. Inside to the switch we have the Ethernet frame, we have the IP, and we have the ICMP. But if we go outbound, here we have the 802.1q. If we go outbound, we have the Ethernet frame with the 802.1q. What is that? That is nothing but tagging. We are putting the tag. We have one frame, it is going outside the switch. Means, let me tell you, I will move. This frame is coming inside. We do not have any tag. But when this frame is leaving the switch, we have the tag. Tag is nothing but label. It is having one label. It is having one tag. What is the tag name? 802.1q. This tag we have in the Ethernet frame. Where we can observe this tag? This one, this place. If you see, we have 00A. Okay, 000A. This A is nothing but, if you see in hexadecimal, A is nothing but 10. We can verify. We can take the calculator here. I will take this calculator. We can write here. I will take hexadecimal and I will take A. If you see in the decimal, 10 means this packet, this frame belongs to VLAN 10. Let me repeat again, maybe anyone is having any question. See here, when we check the packet, okay, we check here, first of all, inbound we don't have any tag here. Okay, when the frame is going to the switch, going in the switch, inside, going into the switch, we don't have any tag here. But when it is leaving the switch, we have one tag here. Okay, that tag we can observe here. We have only Ethernet here, but here we have Ethernet 802.1q. That tag we can check here, this one. We have A in hexadecimal. If we convert that hexadecimal into decimal, what we can say, we can convert. Where is the calculator we opened just now? Let me check this one. So when we put the hexadecimal capital A here, it will convert to decimal as a 10. So by seeing that one, we can say this frame belongs to VLAN 10. Okay, so what we will have, this frame will go here to this switch. When this switch will receive this one, when we open, and we will open now, we open that frame. Okay, we will open this frame now. If you see here, what we are observing here, inbound, when the frame is going into the switch, we have the tag here. Okay, when this frame is going inside the switch, for the switch 2, when he is going inside, how you know inside? This one, inbound means inside, outbound means leaving the switch. This is going inside the switch, this is going outside the switch. So inbound is having the tag 802.1q, but outbound we don't have any tag. So what this switch is doing, this switch is receiving the frame. This switch 2 is receiving the frame. He received the frame. Switch 2 received the frame, and he checked tag. He told, okay, this belongs to VLAN 10. Okay, he will remove the tag. He will remove the tag. Then he will check where we have VLAN 10. He will forward that packet frame in that area. So now he removed the frame. How we know he removed the frame? Because if you check here, you don't have here Ethernet we have. If you see here, we have Ethernet 802.1q, but here we don't have anything. That's why we are saying switch will remove the frame here. But here if you see, we have the tag also. So he will check this belongs to VLAN 10, and he will remove and he will forward to VLAN 10. And if you go, if we do for same thing for the VLAN, this VLAN 20, we can do here from here to here. I am doing here. So now ARP will go, it is going to broadcast, but if you see, it is going only in that particular area. It is not going in different VLAN. ARP is bringing that MAC address and he is giving to him, and now he is sending the packet. If you open this packet, incoming packet will not have the tag, but outgoing packet will have the tag. If you see the tag, what tag we have? 14. Okay, 14. Go here, right here in the hexadecimal 14. If you see in hexadecimal 14, in decimal 20, that means this belongs to VLAN 20. Okay, this belongs to VLAN 20. And now this will go to the switch, and when it go to the switch, he will inside you will have the tag, but outside it will remove. We don't have the tag, and it will go to that particular area. Okay, so this way we have the basic concept about that one, how switch is putting the tag. With the help of trunking protocol, they are putting the tag and they are forwarding that one. So now if we see to our main concept here, we done this lab because to understand this concept. What we are saying, VLAN trunking create one link between the switch that support as many VLAN as we need. In simple words, when we create the trunk port between two switch, it will carry multiple VLAN. In the simple words, what we can say, if we create the VLAN, if we create the trunk port between the two switch, it will carry multiple VLAN. If we did not create the trunk port, it will carry only one VLAN. In which VLAN that interface is present, he will carry only that traffic. Example, if he did not configure trunk this one, he is going to carry only one VLAN, that is VLAN 1 by default. So to make the trunk, to make that interface as a trunk, we have two protocol. We can create with the help of ISL or IEEE 802.1q. We can use this two protocol to make the switch as a, to make that particular interface as a trunk. Cisco has Cisco support two different trunking protocol. One is ISL. Cisco created this one, and this is absolute. If you go for new model of switch, you cannot find this one. In the new switch, we do not have this option. If you remember, here just now we verify in the packet tracer also we don't have this option. They remove this option. If you want, let me show you. When we are checking here, when I write here switch port mode trunk and I encapsulation, I put question mark, I am getting only one option. I have .1q. .1q is nothing but this one only. This one 802.1q. I have only this option. Before we have ISL, that is ISL and 802.1q, but now this is only using, this is absolute. Cisco also removed, but this produced by Cisco, it is working only in the Cisco router, not in any other router. But now no one is using this one. What is the reason for that one? We are going to check now. So what we are saying, we have two types of trunking protocol. We have two types of trunking protocol. Inter switch link, that is ISL, it belongs to Cisco. It is going to work only in the Cisco switch. It is not working in any other vendor switch. And what else we can say? We have the IEEE 802.1q, and this produced by IEEE. We have the institute, that is Electrical Electronics Engineering Institute. They are preparing the protocol, so they developed this one in the February 80 they produced. That's why they are calling 802. They put this name because they introduced this one in the February 1980. That's why they are calling this one. They taken that one 80 and February. That's why they taken 802. So we are saying no need to remember in February 80. Just remember 802.1q. So we have two different method to make interface as a trunk, but no one is using this one. Even Cisco also removed this from his device. But we have the old image also, so we can do this lab also, no problem. Okay, so now what is the advantage or what are the difference between these two protocol, we will see here. If you see just now in lab, what we observe, whenever we have the frame, switch is putting the tag. Tag, in simple words, it is putting the label. Okay, in simple words, in the frame they are putting one label. So by seeing that label, other switch will understand this belongs to VLAN 10 or 20. Okay, this protocol is putting that label. So ISL, we told it is belongs to Cisco, and 802 we told already it is open standard. And here what we have in this one ISL encapsulate ISL header 26 byte and CRC 4 bytes. So total 30 bytes. Means when you have frame, he is going to add extra 30 bytes to this frame. Okay, extra 30 bytes to this frame. Who is going to add? If we are using the ISL protocol, he is going to add that one. That is label. We need to put label. Whenever we are sending the frame, we need to put the label saying that this belongs to which VLAN. So when we are putting the label, he is adding 30 bytes extra data. 26 byte is having the information saying that this belongs to which VLAN, and 4 bytes for the CRC error correction. They are using this one. So now you remember we are adding 30 bytes extra data, encapsulating the old frame into new frame. So it is adding in the old frame into new frame. And here if you see the open standard, what we are happening here, they are using only 4 bytes. They are modifying the original frame. Example, you have this original frame. Okay, they will add in between here 4 bytes. They will put the tag. Just now what we saw, if you see packet tracer, just now what we saw, we have one frame, in between they added the tag. Okay, so that what we are saying, adding a field to the frame header. We add one thing, we modify the original frame and we add the 4 bytes. Here encapsulation means adding. You have this frame, they will add extra here, they will add extra here. That is nothing but encapsulation. Here they are adding 26 bytes and here 4 bytes. Okay, but here if you see this one 802, here we are modifying the original frame. Let me check, someone is joining maybe now. So what we are saying here, let me repeat again. We already studied this in CCNA level. Okay, this is a basic concept. We will do the detailed lab also here. So now what I am saying, we have two protocol, ISL and 802.1q. We have these two protocol. problem, if you use ISL, we have the 30 bytes extra for each packets, each frame, and here we have only 4 bytes, so we will use the less one only. Our original data is adding this number of bytes, so which one we will try to use, more or less? We will use less. If we use less, speed will be fast. So that's why we are now it is available 802.1q only. So these are the two protocol we are going to use in the trunk when we want to create the trunk. So now we will discuss the DTP. Before going to DTP, let me stop this recording, else this video becomes